Okay, we are here with what I think will be our last video for Mod 22. We're taking a look at a hypothesis test here. We're going to relate it back to sample size and also talk about the conclusions that we can and can't draw from this hypothesis test. So this is adapted from, not exactly the same, but adapted from a learn by doing activity on page 147. Data from the Center for Disease Control estimates that about 30.4% of American teenagers were overweight in 2008. So this 30.4% they're giving as our baseline value. So P is 0.304. The percentage was similar for boys and girls. A professor in public health at a major university wants to determine whether the proportion has decreased. So that's going to inform our alternate hypothesis. That is the change we are looking for. He samples 800. So there's our sample size of 800. Randomly selected, that's good, incoming freshmen at universities around the country. Okay, well, that's not good because it said this professor was just interested into whether this proportion about American teenagers had decreased, and yet the sample is only coming from incoming freshmen at universities around the country, and that may not at all represent all teenagers. So that's the first thing we need to be very careful of in this question, is that we're only writing hypothesis statements and drawing conclusions about incoming freshmen at universities, because regardless of what this professor wanted to do, incoming freshmen is the population from which this sample has been drawn. So we can only talk about that population. In this sample, he finds that 210, or about 26% of them, are overweight. So because this is referring to our sample value, we'll have that p hat equals 26%, or 0.26, and that would have come from taking the number of successes, 210, out of the sample size, 800. Okay, so we're starting with step one, our hypothesis statements, both as a sentence and as a symbolic statement. Please pause your recording and see if you can get that step set up. Okay, this is what I have for those statements. The proportion of incoming freshmen that are overweight is 30.4%, which gives us that baseline value, P equals 0.304. And then our alternate hypothesis, remember the change we were looking for was a decrease. So I wrote the proportion of incoming freshmen that are overweight is less than 30.4%, or P is now less than 0.304. Okay, on to step number two. You've got your hypothesis testing rubric right next to you. This is our second example. Why don't you pause the video and see if you can do step two. Okay, this is what I've got here. My sample proportion is 0.26. We're told that we have a random sample. Both of my products, N times P and N times Q, are greater than 10. And remember, it is this criteria together that tells us we have a normal sampling distribution of sample proportions. Okay, so on to step three. We're going to draw our normal distribution of p hat values. We are assuming HO is true and that P is 0.304. So that's what we are putting at the center. Our sample value, our P hat of 0.26, therefore must be to the left because it's a number line, and 0.26 is less than 0.304. The next thing we need to do is write our p-value as a probability. So we know that the p-value is the probability that our p-hat is equal to the 0.26 that we got, or something more extreme. More extreme, further than from center in this case, is less than, under the condition that population proportion P really is 0.304, just like HO says it was. So we're going to go use our proportion stat function and come up with our p-value. We're also going to get our test statistic from that same proportion stat input. So let's go over there. Here we are in StatCrunch. We're picking stat, proportion stats, one sample with summary. Our number of successes was 210. Our number of observations was 800. Our hypothesis test was testing that P is equal to 0.304. Our alternate is less than, and we click compute. So 210 out of 800 gives us that sample proportion of about 26%. The standard error is the standard deviation of our sampling distribution, but we don't really need it for anything from here on out. We've got our test statistic here, and our p-value here. So let's go and report both of those. So our p-value is 0.0054. So under the condition that the center of this distribution really is 0.304, getting a result like 26% or smaller only happens about half of 1% of the time. So that seems like it's an extremely unlikely event. Let's put that together with our test statistic, negative 2.55. So again, here's about 1 standard deviation below, 2, 3, and our p-hat value is about right here, about 2.5 standard deviations below the mean. So we've got an unlikely event. That makes us want to reject the thing we believed was true and instead support the alternate hypothesis, support the change that we were looking for. So I suggest everybody pause the video, see if you can write your if, then, therefore sentence for this conclusion. All right, this is what I came up with for my final conclusion here. Remember, in the if part, it's about HO being true, because we assume that's true when we set up our sampling distribution, when we calculate our p-value. So if the proportion of incoming freshmen who are overweight is 30.4%, then our sample results are highly unlikely. How did I get that? Because the probability of them occurring is so tiny, because our sample result is so far from center, more than 2.5 standard deviations from center. Therefore, We're rejecting HO, we're supporting HA. We would say our data supports the proportion of incoming freshmen who are overweight is less than 30.4%. But really, just overarching idea here, we assumed 0.304, was the center. We came up with an outcome that is just too far away. So instead, we believe the center is something less than 0.304 because again, if that curve, for instance, moves over here, well now, this sample value of 0.26 becomes something very usual, right? Here it is where the curve is tall. It's only where the curve is short if the curve is way over there, where HO says it is. All right, hypothesis testing, great, big, important deal. But we're going to keep doing this over and over and over again. We're going to do it with means, then we're also going to do it comparing two populations. So you're going to have lots of practice at this process. Again, when you're in OLI, they're usually just asking you, about one step of this process, but on your final exam, you will be required to demonstrate all 4 of these steps. That also reminds me, though, that, you're home and it's open notes. So of course you can look at your hypothesis testing for means and proportions grading guidelines. But even when we are in class, I give my students this sheet of grading guidelines. So this isn't anything that anybody ever needs to memorize. You always have access to everything that's on this sheet. Okay, oh goodness, I was just going to sign off and say happy hypothesis testing, but we didn't talk about how this relates to sample size. I was going to relate this back to sample size. So I'm going to go over here in StatCrunch. I'm going to open the applet. When we're exploring ideas, when we want to see what happened when different parameters change, that's when we use these applets. We never use these applets when we're actually creating something, when we're creating a confidence interval, when we're creating a hypothesis test. They're just for exploration. So I'm going to go back and explore here with sampling distributions for a minute. This is what we did in that Mod 18 worksheet that hopefully you went through. I'm going to set this up to be binary. Let's see, P was 0.304. So I'm going to set this up with a target population proportion of 0.304. And what we just did was using a sample size of 800. So I'm going to click 1,000 times. And what we see down here in the bottom is that simulated sampling distribution of sample proportions. I'm going to zoom in on the x-axis. So here's what I want to point out to you. Of course, our target proportion 0.304 is right at the center of that distribution. You can see how close this particular simulation happened to get. And notice 0.26, which was our sample proportion, is so far away from center. You can see how short the curve is out here, okay? So that's how we know that 0.26 is very far away from 0.304 because it is where the curve is short, okay? But I want to go ahead and change this sample size. I'm going to bring it way down to 100. And now notice that 0.26 is in here, right? It's now where this sampling distribution curve is still fairly tall. So now getting a sample proportion is not that unusual anymore. So I just want you to notice again how this curve changes with sample size. We increase the sample size back to 800. That brings the standard error way down, and now 0.26 is way out here where you hardly find any data. So with great big sample sizes, it is easier to reject your null hypothesis, right? 0.26 is very far away, gives us strong evidence to reject that null hypothesis with this sample size of 800. But if I had that exact same sample proportion of 0.26, but I had it with a sample size of 100 instead, now I don't have evidence to reject my null hypothesis because I'm in here pretty close to center. So it's much easier to get evidence to reject your null hypothesis, to support your alternate hypothesis when you have a big sample size. It really brings out those differences between what our baseline value is and then what we're getting in our sample. All right, that really is the end of this mod.